Greetings, this is Art Devine. What we have here are specimen samples of sputtering and showing the steps in the manufacture of thin film recording heads for the disk drive industry. These targets were retained from some years ago. The typical target on this type of Perkin-Elmer sputtering system that we had, known as the 2400, which was originally used for manufacturing of most microcircuits, has now been deployed. The target is, sometimes it can be made of stainless steel. These happen to be a molybdenum alloy that won't levitate or tip upwards to reach equilibrium during the ionic pressures of the sputtering process. Now, ionic power is always present. When the radio frequencies are appropriately high enough, that can cause these trays to levitate, but they won't crash or go magnetically into the targets, which is the cathode for this, and these plates rest on a copper plate, but below that, which is water cooled like that, and the trays we put on top of that to hold the work, which you can see whether they're plates like this. In this case, these targets were copper colored because plates such as these were given a copper coating and then to be photo etched afterwards to create conductive lines across a ceramic substrate like that. So the copper that you see here, and on the other side of this one was one of the more popular materials that are sputtered to make microcircuits.
Why is this green?
Why is green? Well, you're looking at one of the colors of diffraction. The coating on this was intended to be 11 millionths of an inch. Unfortunately, this lot was abandoned because we had a power interruption during the process, which ruined our entire day's production, and this is some remnants from that, like that. It was just a routine brownout, and we were given no notice on that. The entire work of 40 people was ruined in that 2-hour lapse of energy in the middle of the day with no warnings.
Would they normally be green?
No, it depends on, you can see at a certain point, I don't know if the light is for it to pick up, now you see the purple color,
yes,
which is a transitory color between red and green, which actually comes out to be brown when you mix pigments, red and green. That's how brown is made. That blue and yellow, as you know, make green, like that. Right. But you see, when you're depositing it, all these colors of the rainbow are just different levels in millionths of an inch of coatings. In this case, we're depositing glass, so that's quite transparent, and it's picking up the fact that the surfaces on these rods have been lapped to the perfection of as a diamond would be done. They're absolutely highly polished before the deposition was put on, and it basically becomes as polished as the substrate is when you're only putting a few millionths of an inch of glass on the top of that. This particular glass, I can say now, is very similar to the same glass that in the old days was used to make the windows of the cathode ray tubes.
Okay.
In fact, I was paid $250,000 by a jilted company to get off the hook by letting them know what kind of glass I used. Now, this was 20 years ago, so it's no longer a big secret.
Thank you very much for your time, Mr. Devine. Have a good day.